Alright, hello and welcome. Today is April Fool's Day, but we don't have time for April Fool's jokes. But today will be very simple. We will work on our first virtual lab. This will be very similar to the one that the AP1 kids did. So, their stuff got canceled, so they had to do your things. um, so if you have a sister or someone who is also in AP1, then you can ask them for help. If you don't, then ask Dennis. Hey, Dennis. Uh, yeah, you can ask Adam. So we're going to use the same virtual simulator. You should go to your Canvas, download the lab, and it also has the link to go to this virtual simulator. You can also go through the FET website under Physics, Circuits. It's a Circuit DC kit. Huh? Yeah, that's what I said. Basically, the AP1 kids also did this one because we all had to use the same virtual kit. uh, so so the file should look something like this. And today we're just going to do the the first part, which is resistors in series, where we put resistors one after the other. That's what series means. They're in series. Uh, they're consecutive resistors, if you will. Okay, and then all of those resistors are eventually connected to the battery, as you see these wires. And so, just like using Legos, you have to construct it using our circuit elements. Now you can change the view. Remember, this is the same thing that I showed you last time. So you can change the view so that it looks like the circuit elements we have in our diagram. You want 3 resistors. 1, 2, 3. We want some wires. And let's go and change it to conventional current because we don't like electron flow because that's backwards. There we go. We're going to use the conventional flow for everything. If you take a look at the circuit, you see that the battery has the big line on the left side and the small line on the right side. So we need to rotate it. And to rotate the battery, you can of course rotate it manually, or you can apparently click on it and then hit the rotate button. Rotate, and now the battery is facing the other way. If you go back to the normal view, you can see the battery is facing left or right. Let's go and connect it to. Let's go and use a little bit of wire here. There we go. It doesn't really matter how much wire you use because these wires are ideal and they have 0 resistance. But in the real world, of course, you want to minimize the amount of wires because it adds resistance. Right. There we go. And there's our circuit and it's working. Yay. Once you make this, you have to use your own value. So click on each element, whether it's in normal view or diagram view. Click on each. Let's turn it off first. Let's turn it off. Click on each element and change the values. The default is 10, of course, but you need to use 3 different numbers. And it could be in any order. It doesn't matter what order, but you do have to make sure that the battery is 30 volts. That way we'll get some nice numbers. There we go. Alright, so make the battery 30, make the other 3 some other numbers. Here's a voltmeter, and this is the ammeter. Remember, for voltmeter we want to be connected to the battery and then use the probes. These are the probes, the pencil-like things. And you want to touch the metal contacts, these gray circles. And by making contact at the metal parts of the resistor, you get some voltage. Now, of course, you might get negative voltage if you have your probes touching this way with the black one touching on the the red side and so on, or you could just swap them. If you do red over here, black over here, this will give you the positive value. It's the same value, it's just red backwards. In your worksheet, just write down the positive number, and we'll just say that that is the voltage drop across the resistor. All right. But in reality, yes, it is true that the resistor is dropping that voltage. It is subtracting that voltage away. Okay. So if I do it this way, the battery will be negative. Oh, whoops, the battery. There we go. Whoa. Negative, negative. If you want to do the second one, you go from the start. Oops, let's start with red. So let's say you want to measure the second one only. You put the red one here at the front and the black one here at the back, and that'll give you the voltage for R2. So R1 being the first one, R2 being the second one, R3 being the third one. There are also R1, 2, a combination, 1 and 2. If you look down here, R1, 2. R1, 2 will be the combination of 1 and 2. So it's the start of 1. So let's go and put our probe at the start of number 1, and then put the second one at the end of number 2. So if you start from 1 and then skip the middle and then go all the way to the bottom of number 2, that's R1, 2. Okay? And I want you to notice patterns. Look, here's R1, 2.86, and here's R2 by itself, 9.57. What is R1, 2? Whoa, it's 12.43. Interesting. Alright, so that's how you measure. If you want to do 1, 2, 3, you do from the start of 1 all the way down to the end of 3. Whoa, look, it's 30 volts. Alright, if I want to measure current, make a break. So let's say you want to measure I1. So start here, use the scissors to cut open the circuit. Cut. Now there's a break. And inside that break, we'll go ahead and insert this ammeter, and so the current will be forced to flow through the ammeter and measure your current. Maddie, please refrain from spamming caps. All right. Good morning. And it doesn't matter technically if you do it at the start or at the end. Okay, because in series, as you'll find out, there's only one pathway, so the current flow, look at the arrows. Whether you're measuring it here at the bottom or here on the side, the speed of the arrows is the same for the whole circuit, right? So the idea is that you get the same value, whoa, no matter where you are. All right. Okay. So use your voltmeter to measure the voltages, use your ammeter to measure all the currents, right? And then you have to use this power equation. Power is equal to current times voltage. So let's go to honors, HP. Here we are. OneNote. Okay. So power apparently is equal to I, the current. I should say power P. Power capital P, not lowercase p. Lowercase p was momentum. Capital P power is equal to I times V, or delta V. Power is P, and P is measured in watts, so here are the units. Capital W, watts. Current, I, and of course current is measured in amps, A. have voltage. Voltage V is measured in V's also, which is volts. Close parentheses. Alright, so once you measure your current and your voltages, you can multiply the two numbers and that'll give you your power in watts. Power in watts. Okay. Alright. And then try to answer all the questions. We will go over them tomorrow. Alright, I guess that's it for today because this is just a demonstration of how to use the kit. You know, go to your Canvas, download the worksheet, save it as a PDF and upload it. Due Saturday, of course. But, you know, hit File, Save As, and then save it as a PDF. Yeah. Well, it's not about the show today. It's about you doing your work today. So, wait. What are you saying, Ella? WDYM. What do you mean? Enough? There's never enough physics. Oh, okay. Well, this is all from my end. You now have to go and open up your simulator and use the simulator to make all these measurements. Remember, you get to choose your 3 resistors, R1, R2, R3. Just make sure you label them and write them down. Okay, and make sure they're 3 different numbers. They can't be the same number. Alright, and however, the battery has to be 30 volts. So make sure the battery is 30. Okay. The choice is yours. It is Wednesday, isn't it? Yowza. Alright, see you later. Thanks for tuning in.